Okay. So we've sent na the link for recording slash live stream. Just wait for it sa batch GC. Francis should be forwarding it. Let's wait until 8:15. Is that okay with you guys? That's regardless of how many people, let's start na. Since my recording din naman.
Well, yes. Okay.
Okay, I will take that as a yes. Okay, game. I'm gonna share my screen. Let me know if kita siya. Can you guys see this?
Yes, kita.
Okay, thank you. So, ayun, hello guys. Welcome to RIE 27 LU1 review. Unfortunately, wala kaming nahatak na people who've already taken the course and can, give like, I guess, a more comprehensive review. So I guess you guys will have to settle for me tonight, unfortunately. Yeah, I'm kidding. I tried my best naman. So, ayun, the flow of this review will be quite simple. Pero caveat ko lang because the samplex from Acadres is a bit kasi it's like super comprehensive. Um, the likelihood is now we won't go through everything, so we'll still cap it at 8 to 10, just because I feel like at 10, it won't be productive from my end or from your end na rin. So we will focus on just covering as many concepts as possible. So that's why we're gonna start with the conceptual questions. On top of the fact na wala siyang solution, so answer key lang meron. And then we're gonna do a bit of the problem solving questions. Probably the slightly more intuitive ones lang, kasi those are the ones na I'm pretty confident I can explain well. Okay, so with that caveat out of the way, just make sure that you have a copy of the questions. I'll send it again sa Discord just so you guys can follow along. Yeah. Ay, wait, these are the first. Ay, tama pala. These are the questions. Okay. Yeah. So with that out of the way, let's begin. So let's start with A1. Modified true or false. So the first question is: negative binomial has memory. Does negative binomial has memoryless property? So we need to recall two concepts here. The first is what it means, what negative binomial RV is, and then second is what the memoryless property is. So the negative binomial property basically just states that we are looking for the rth success at the x trial. And it's given by this equation. So these are one of the things na kailangan nating kabisaduhin. Just to explain what it looks like conceptually, it just basically means na um, what we're trying to solve for here is given na lock na on the sixth trial, we are going to get success number 4. Like in this example, fourth success at sixth trial. Which means now we're looking for the probability na we're gonna get a sequence that could look like this, for example, or could look like this, right? Kasi may 3 successes ka, tas the fourth success is on the sixth trial, etc. So, what that therefore means is na, in negative binomial, we're trying to get like the somewhat combined probability of these 5 specific events, and then all the possible permutations that will give us 3 successes before the by the time you have 5 trials. Sorry, nasobran ko pala ng isa. Shit, wait. Oops. Nasobran ko pala ng isa yung it's 7th na. So there. Yan. Okay, kunyari na lang that's 5 trials. So, the specific combination na you have like 5 different successes or 3 successes at 5 trials, and then the 6th trial is a success na. So that's basically negative binomial. For memoryless naman, usually the keyword in questions is given that. And it's nice to know na it's somewhat interrelated with conditional probability. So for example, taking this same expression, yung fourth success at sixth trial, what we can do is now take a modified version of that. So let's say instead na it's the fourth success at the sixth trial, given that the first 2 are failures. So what this means is na, di ba dito, like the first two entries, we're not sure kung ano siya, success or failure. But in this scenario, parang it's locked na these are going to be failures. So what that means is na to get the fourth success at the sixth trial, if the first 2 are failures, the other 4 of them have to be successes. So if you think about it, kasi hindi to siya magiging factor it doesn't factor into the probability, because obviously these are certain na the first 2 are failures because it's given, meaning na this whole expression, the fourth success at sixth trial, given that the first 2 are failures, is just equivalent to the expression na the fourth success, you get your fourth success at the fourth trial. Kasi effectively, you still have the same here na kunyari you have 2 fake scenarios here. Now these can be failures, and it will not change the probability of this whole expression. So what that implies therefore is yung negative binomial is memoryless, and therefore the answer to this is true. So that's for item number 1. For item number 2 naman, by the way, if you have questions, I think you guys will have to unmute kasi I can't see the chat. Pero feel free to interrupt me anytime. Again, I'm trying to get through these as like efficient as possible kasi para madaanan pa natin yung problem solving. So yeah, let's move on to the second question. So for any discrete random variable, e and then parenthesis x squared is greater than or equal to e x and then the whole expression squared. So we'll have to first write this in, I guess, terms na we understand more. So the first thing we'll rewrite is the right side. Remember na, the expectation or the expected value of PMF is basically just the mean. Di pala. Sorry, di siya U. It's actually mu. So it's like something like this. Ata. Something like that. So, basta it's the mean. Ito. So basically, this is just the mean squared. However, yung left-hand side is a bit more tricky. Kasi effectively, what this is it's like basically a new function, expectation of y, where y is x squared. So it's completely different. But what we can do, given that we know that na, is just break this down. So, recall lang na this is a given from slides. Na the expectation of a function is just the summation of all of x, of all the entries in the PMF. So h of x times all the probabilities at that point x. So this is also sometimes written as p of x kasi probability. So what that means is na for every entry x, you have x sub 1 times the probability of x sub 1 plus x sub 2 times the probability of x sub 2, etc. So let's now look at the critical difference between the two. So if we're talking e to the x, then you square the whole thing. If you think about it, hindi magbabago yung probability, diba? Kasi it's still the same thing. The difference lang is na it's still the same event except the value of the event got squared na. So the probability of the event happening is still the same. Conversely, if you square the whole expectation value, you're pretty much squaring the whole mean. So if you see the difference here, dito yung x lang yung nasi-square sa first case. In the second case, if you distribute the two, so magiging squared to, but also the probability becomes squared. Just to give you guys an illustration of what this means is, let's take for example, a scenario where we let x be the number of heads in two coin tosses. So this will be the PMF basically of the whole thing. Like it's pretty straightforward, right? So you have a coin, you start here. Head, yung first flip, heads, tails. Second flip, heads, tails. Heads, tails. So the probability of getting heads, getting two tails is 1/4, kaya 0. 0 number of heads. The probability of getting one head is either this scenario. Either this scenario. Oh shit, sorry. For real, eto. This scenario. Or this scenario. So that's 2/4 or 1/2. And then finally, just the value of the probability of getting two heads naman is just 1/4. Ito. So then, if we, for example, do the first scenario where we just square the inside, yung mangyayari is let x be the number of heads in two coin tosses squared. So that's what gets added here. What that means is na, as we mentioned before, yung first terms lang sinisquare. Kaya siya ganito. And you eventually end up with this. Right? This is just like adding these together. Conversely naman, if you square the mean, basically what just happens is, mali pala to. Basically what just happens is this, and then, so again, instead, yung difference na is, may square dito, wala dito. Wait, let me just show. Okay. So, as you can see, there is a difference. So if you guys notice, this is bigger than this. Pero obviously, we have to check if if it holds true for all for all discrete random variables. But what I want you guys to notice is, 'di ba, as per yung axioms on probability, the probability of any event happening, let's say x sub 1, will always be less than 0, or greater than 0, sorry, but less than 1. So what that means is na, sorry, I should have put it to space na ginawa ko na. Less than 0, greater than 0, less than 1. What this implies is na, because it is a fraction, so 1 over something, or basta it's a fraction, it's a 0 point something, diba? 0 point something. What that means is na, anytime you square it, yung square niya, diba, obviously, will have to be smaller. Does that make sense? Kasi, since less than 1 siya, so it's a fraction, diba? So like parang 1/2 times 1/2 is obviously less than 1/2 because 1/4 is less than 1/2. And this pattern exists for basically all fractions or all numbers greater than 0 but less than 1. Does that make sense? I hope it does. So, what this implies is na, anytime nagsisquare ka dito, anytime nagsisquare ka ng probability, that will always be smaller than, the values here, like, so ito, will always be smaller than the ones here. And what that implies is that the expression where you square the mean will always be smaller than if you, or always be smaller or equal to the expression where you have the inside lang yung naka-square. So this means na the statement for any discrete random variable, blah blah blah, that is true. Does that make sense? I think this one is like one of the harder true or false questions. I'm assuming there are no questions naman. So if that's the case, then we can continue. Yeah. Okay, I can now see the chat through my other device. So you guys can ask questions through chat. Okay. So then we can move on to number 3. The priori source of probability determines probability by means of historical data. I don't think this was taught, at least sa class ko, this was not taught. So let's just go through this. I looked it up, and it's basically like prior just means na you assume it's equiprobable because you have no idea kung weighted yung probability niya. And then post prior is just, you now have information on the probability of each event, and therefore hindi mo na siya tinitreat as equally probable. So that's basically just it. I don't even know if this will show up sa exam natin. So let's just move on na. So basically it's false because prior just means na you are basing it on face value and not using any data to account for yung weighted probabilities. Okay, so that's for number 3. For number 4, for 0 less than p less than 1, the mean of the binomial variable is always numerically smaller than the variance. So this is just a matter of kind of playing around with the numbers. So the most important part of this question is to remember what the values are in the first place. In this case, for the binomial random variable is just, ito yung expectation niya. So this is on the slides. And then ito yung variance niya. So then we just want to compare them. Yung statement says it's always numerically smaller. So let's test that. So linatag ko lang on both sides. Important to note na this is for 0 less than p less than 1. And then yung mangyayari is you'll end up with this. 1 is less than 1 minus p. Obviously, we can use the endpoint siguro just to test kung if it makes sense. If p is 0, it becomes 1 is less than 1, which is obviously not true. And then if we put the other end, 1 is less than 0 yung statement, which is obviously not true. So therefore, by contradiction, it is false. Yeah. So what we did here was basically just use the definitions, tested it by assuming the original statement to be true, and then we were able to cancel everything, yung NPs, and then we found out na the statement cannot be true. So the statement must be false. So that's just like quick rundown lang. So now, we'll move on to number 5. And I think 5 is a bit concept heavy then. So as small n over big N approaches 0 in a hypergeom distribution, probabilities computed using binomial approximation become closer to the actual probabilities than when small n over big N is large. Okay, so let's recall a few things lang. The first is now, big N is obviously the population. Meaning it's the whole thing na pinagkukunan mo ng samples, while small n is the sample size, or the amount of, or the number of draws, or the number of tests, or the number of trials, ganun. So basically small n is a subset of big N. So the first thing we want to do is, kasi kino-compare siya, 'di ba? Whether or not mas malapit yung hypergeom to binomial when small n over big N approaches 0, or when small n over big N is a large number. Yeah. So what does it mean when small n over big N is approaching 0? Diba what that means is that you are taking very few samples, right? Or near 0. Wait, does somebody have a question? Somebody's unmuted. I'm assuming wala. Nobody has questions. Okay. So, you have few samples, and therefore near 0 yung amount of samples na tinitake mo. On the other hand, when small n over big N is approaching a large number, or technically max 1 siya. So we're talking like very close to 1 but not 1. You're taking many samples. So now, we know na usually the difference between when you have few samples or many samples, usually halata yung difference when we're using a random variable that is with replacement in comparison to without replacement. So now, what we want to figure out, since we figured out this na, is which one yung may replacement, which one yung wala. So in this case, it's wait lang. I have to double check. I think it is. Yeah. So hypergeom is wait. Suddenly I have forgotten. Okay, so okay. I need people to double check me on this. Pero tama naman ata. So no replacement. With replacement is binomial. Without replacement is hypergeom. I'll fix that. Wait lang. Sorry. So with replacement, binomial. Without replacement, hypergeometric. Okay. So what we can do to just find the general answer for this is, let's simulate a scenario with and without replacement. Let's say there are 4 red pens and 4 blue pens, right? We want to find the probability of getting a red and a blue, and then a red and a blue, or a red then a blue, then a red then blue then blue. The reason why this matters is makikita natin yung difference when there's replacement and there's no replacement. So, and also, this compares a small sample to a big sample, which is what we noted was the difference between the two na pinakita kanina. So, with replacement, let's do with replacement first. Same lang to, diba? This is just 1/2 times 1/2. Oops. This is just 1/2 times 1/2. Ito naman, this is just 1/2 times 1/2 times 1/2 times 1/2. Pretty straightforward because it's with replacement. Without replacement, it's a bit harder, but it's like this is 4/8, and since without replacement siya, this becomes 4/7. Dito naman becomes 4/8 times 3/7 times 4/6 times 3/5. So now, what you want to do is just calculate all these. So this is just 1/4. This is 1/16. This is This is so then this is 4/14, which is just 2/7, and then this is wait. Okay, this is 3/35. So as you can see, it's fair to say na when the sample is smaller, the values of with replacement and without replacement are still quite close. Kasi hindi pa yung if you compare their last terms, it's kind of similar pa in comparison to yung last terms na marami na yung samples. So what that means is just having less draws or having a smaller sample means na you have closer values. So what that means is na the answer to this is just the answer to this is true kasi it just means na when the sample is small or when small n over big N is closer to 0, mas accurate yung sagot. So this is just true. Okay. That made sense. And then so let's move on to 7. So for number 7 naman, it says that the Poisson random variable is a continuous random variable. This is just obviously false. I don't know. I put true. Hey, wait. This is an error. Dapat false yan. Yeah, so this is false kasi just reviewing discrete random variables na rin. So I'll integrate it na. So these are obviously the 7 na gagamitin natin on top of yung uniform. But uniform is straightforward naman. So you have hypergeom and then multivariate hypergeom. Basically, this is just a simplified case of this. Same thing with binomial and multinomial, geometric and negative binomial. So hypergeom, diba, is just like getting. This is just basically the without replacement na case. Getting the probability of how many what is the probability of X amount of what is the probability of having X items or X things if on average this is the existing rate. So that's basically the use case for these two. For these two naman, binomial and multinomial, it's similar, pero the difference is 1, ito is without replacement. 2, this is also used if you are doing successive trials that are independent because it's with replacement. If you're doing the same thing over and over again and one is independent from the other, ito rin yung gagamitin mo. This is also the one you use kapag unknown yung specific like rate. If it's just estimated at p equals something. So for example, if you say yung defect rate ng isang factory is like 2% per 100, that's hyperjump kasi 2% of 100 is certain, you're certain that's 2. But if it says na the defect rate is p equals 0.02, then you use binomial or multinomial. Geometric naman and negative binomial, it's just the amount of times it takes before a certain success. So for negative binomial, diba, it's the rth success at x trial. And for geometric naman, it's just a special case where you're looking for the first success on that trial. But if you plug in the case of first success and negative binomial, you'll just get the equation for geometric. So actually, you don't like, it's kind of like you don't have to memorize this even because this is just a clear special case of this. Moving on lastly sa tinanong ng question in the first place, which is Poisson. So we know that it's obviously one of the discrete random variables. So this is just false because it's not continuous. Pero the thing with Poisson is you usually encounter it when you're partitioning something arbitrarily through a rate. So for example, n things per time or n things per distance. And then you ask for the probability now when you do something else, like do a different time or take a different interval of distance, what is the likelihood that you run into x things or you get a different number of whatever it was initially given. So that's basically Poisson. So it's obviously false. It's not a discrete random variable. For 8 naman, which is just connected to 7. The average in a Poisson distribution can be negative but not 0. So recall lang na the average in a Poisson distribution, so yung given is called lambda. So it's equal to the mean. It's also equal to the expected value. So usually in like an overwhelming majority of questions, ibibigay naman yung lambda. So that's not a problem. The question here asked is, it can be negative but not 0. The way you can do that is just to test, like, what is the role of lambda in the equation. If you remember, this is going to be, so this is basically it's not working. Again. This is basically the equation of the Poisson distribution. So, lambda pala. So, lambda. And then this is lambda x. There. So, since important na naka-negative siya, it massively changes the equation if it's not negative. So what this implies, on top of the fact that it's a discrete RV, what this just implies is na it cannot be negative kasi otherwise this equation will just break. On top of the fact that it's also like you're looking at the rate of how many things per time or per distance, and it's kind of weird to have negative of something per time or per distance. So that just overall implies na this is false. Okay, so that's for number 8. For number 9 naman, okay, so I wrote it down na rin. Assuming equally likely probabilities, set A has a larger variance than set B. You can do this manually if you want, but it's very difficult to do so. So what you just want to remember is what variance is conceptually. Variance conceptually is basically just the average of the sum of squares away from the mean. So you're taking all the sum of, so ayun nga, you're taking you're taking sum the sum of squares, right? So expectation, diba, is just the summation of all the squares. And then you're trying to estimate how far they are away from the mean, which is why you have minus mu squared here. So what this means is we can just eyeball what the probable um, mean is in both these sets, or we can also just calculate it. Pero let's say we're under time pressure. You can eyeball this, diba? This is like around 2, probably, yung ano niya. Because it has zeros, ones, twos, and 3. So it's probably like 2 point something, or 1.9 something. Ito naman is probably around 1/2. So, if you add up all the squares of their distances, you can probably get yung 2, yung 1, is like high 1 pala, 1.8, 1.7, like around that, right? Because it's 0 to 3. You can probably expect the distance from yung 1 point something region to 0, and then on the opposite direction, 1 point something to 3. If you add that all up, considering that these sets have the same cardinality, will probably be bigger than from 1/2. Sometimes you have to add 0.5 to get from 1/2 to 0, and then vice versa. So overall, yung distances nila from the mean is probably higher in set A. So what this just implies is set A probably has a larger variance than set B. So this is true. Alternatively, you can just also solve this manually if you want, but it takes time. So for number 10, the variance of a Bernoulli random variable is p minus p squared. So this is just another case of kailangan nyo siya kabisado. So if you obviously distribute this becomes p minus p squared, which means it is true. Yeah, there's not really much concept there. Like, legit tinitest lang kung kabisado nyo. So that's for number 10. For number 11, A union B, the whole expression prime, is equal to A prime intersection B prime. So, if you guys remember, this is just De Morgan's law. The way I like to think about this law is you're distributing the prime across the whole thing, but not in the sense you're directly distributing. So, it's important to note this is not true. So that is not true. But what I mean by distributing the prime is you also distribute it to the symbol. So obviously, union and intersection, they're not exact opposites of each other. But when it comes to set operations, parang they're kind of seen as like the opposite-ish, but not exactly. So the reason why that's important is you can treat it that way, like just as a mental shortcut. Para you can just do that. So you're distributing the prime to A, so it becomes A prime. You're quote-unquote distributing the prime to the union, which makes it an intersection. And then you're distributing the prime to B, which makes it B prime. And then the same thing applies here, so it just becomes A prime union B prime. Which means number 11 is this, and therefore the statement is true. Okay, that's for number 11. For number 12, so this one I think is the most conceptually packed out of all of them. So for a hypergeometric random variable, the minimum value of a random variable with non-zero probability is n plus k minus n. So this requires a bit of solving. So let's first recall ano yung hypergeometric RV, which is just this equation, diba? If we're looking for the minimum value, then we want to find what seems to be the most unlikely scenario. What seems to be the most unlikely scenario. So, the way we can do that is to think of what seems to be the most unlikely scenario when you have a sample size of k. When you have success cases of k, what is the most unlikely scenario na you need a certain amount of success cases? If you think about it, yung pinaka unlikely is na you get every single one of the success cases, right? Which means na in this scenario, k is equal to x. So this means that this is quote unquote the lowest chance. The lowest probability of happening. Or alternatively, k is equal to 0. But I think it's easier to illustrate it when k is equal to x. So let's plug in this specific scenario. When k is equal to x, so nababago lang to. So this becomes k choose k, n minus k stays the same, small n minus k instead of x, and then big N choose small n. So this means na so the first thing pala na we did to change this further is we recall the combination definition. For any n choose r, so for any since you're converting it, diba? Parang ganun siya. For any top choose bottom, basically, n factorial is over r factorial and then n minus r factorial. So it's a bit weird to so I'll try to explain it as clearly as possible. So top so sa taas is top factorial over bottom factorial and then top minus bottom factorial. So here it's quite intuitive, quite simple lang. K choose k is just one. There's only one combination of ways to choose the whole set, right? Because order doesn't matter. So this is automatically 1. Dito naman, the top factorial, so n minus k. The bottom factorial, so that's n minus k dito. And then, n minus r, so top minus bottom. So, n minus k minus n plus k. Kasi double negative, diba? Double negative, so positive. So, the k's cancel out. So, effectively, naging ganito siya. N minus k minus n plus k plus k. The k's cancel out. Therefore, you're left with big N minus small n. And then you repeat the same process here. Big N factorial, small n factorial, big N minus small n factorial. So then these cancel out. And then what happened here is basically like, if you think about dividing n minus k factorial over n, what you end up just getting is all the terms that are n but not n minus k. Actually, sorry, na-flip ko to. So this should be the denominator. There. So basically, this is just like, you take all the terms of n that are greater than n minus k. So n times n minus 1 times n minus 2 all the way until n minus k plus 1. Same thing here. At this point, this cannot be simplified further na. So we know for a fact that this is not equal to n plus k minus n, and therefore, by contradiction, this statement is false. Okay, so that's for part 1. Are there any questions muna on any of the items? I'll check chat then. I'm assuming we're all good. Okay. Wait. Sige. So I'm assuming none. I'm just checking the chats and everything. So we're good. Now we can move on to part 2. So For part 2 naman, same thing lang, modified true or false. The first part is just straight true or false, and then the second part is modified. Okay. So, for part B, say we are given a geometric RVX wherein we are interested in determining the probability that the first success occurs in the mth trial. If we know the first O trials have resulted in a failure, according to the memoryless property, we calculate for P x equals m minus 0 instead of P x equals 0. So, this is just a matter of being careful. So it says already that the first O trials have resulted in a failure. So what that means is we are not looking for O. We are looking for M. And therefore it just means now we're looking for success at the mth trial and not the oth trial, because we know that the first O trials are for sure a failure. So by memoryless property, we can just discard them as unimportant. So, di na siya kasama. And that basically just implies na this is false. And the right hand side, the right statement should be P is equal to X. B X equals to M. Okay. So that's for part 2, number part 2 number 4. So for number 5 naman, this is like just super technical stuff. So we just have to be careful here because we could like lose free points on this. So number 5 is just an event is an element of the sample space. You might think this is like intuitively true, pero let's take the sample space where the events are, or where the elements in the sample space are 1, 2, 1, 2, 1, 1. The event of getting a 1, diba, is actually something that can happen 4 times out of the whole set, which is 1, 2, 3, 4, 5, 6. So the event has a 4 over 6 probability. But the more important thing to take away here is na the event itself, the act of getting a 1 from this set, is not an element of the set, but is rather a smaller set, or therefore a subset. Right? Kasi the ones here are a subset of this set, set S, where it's comprised of like 4 ones and then 2 twos. So this is false. It's not an element, it's a subset. It's a subset of the sample space. Okay. So I think that's just an important clarification. I don't think it's gonna be super like pivotal, pero just in case na lang. It's relatively important. So next is, if M and N are mutually exclusive events, then P M union N is equal to PM probability of M plus probability of N. So again, let's try to just use existing concepts na we know. So one concept na we know is the addition rule, diba? The addition rule is basically for any union P A union B is just adding the probabilities together and then subtracting the intersection. But the specific difference here is we're talking about, so this is general addition rule. So the specific scenario we're looking at though is na these are mutually exclusive events. So what this means is we have to understand first kung ano yung PA intersection B for mutually exclusive events. Diba, if they're mutually exclusive, that means na they never intersect. They have no scenario where if A is true, then B is also true. So parang kung Venn diagram yan, these are basically two mutually exclusive events. And what that implies is na their intersection is 0. Or, sorry, the intersection is an empty set. So this or this. And therefore, the probability of their intersection by the axioms of like probability, 'di ba? An empty set will always have a probability of zero. I will always have a so an empty set will always have a probability. Kunyari empty set na lang yan. Can't write the brackets. Terrible. So zero. So this means that this is zero. And therefore this is zero. And what that means is we are left with PA plus PB in the original question, PM plus PN because they're mutually exclusive. And therefore, this is true. Okay, for number 7, we're basically asked to compare a CDF and a PMF. So, let's first start with the probability distribution function. So let's say we're given this. F of x is equal to basically 0. The probability of getting 0 is 1/8, 1 is 3/8, 2 is 3/8, and then 3 is 1/8. So relatively simple. There are two ways to write this. The first is through PMF, and then the second is through CDF. So the difference is CDF is continuous, right? Because it's like continuous, like literally in the name, continuous distribution function. And the PMF is discrete. So it's probability mass function. Ito yung kailangan mag-add up to 1 if you want it to be a valid PMF. So, it basically asks if the value of x is always greater than the PMF value for any value of x. Technically, if you think about it, sa gitna ng mga whole numbers, yung PMF, yung value niya is 0. So 0.5 it's 0. In comparison, yung sa CDF at 0.5 it's 1/8. So that's how you can think about it. So at that part it's greater. But there are parts where they are equal, right? At 1, this is technically at 3/8, right? Because you factor in you're adding them together. So at same lang siya, 3/8 dito. 3/8, 3/8 here. Same thing sa kasi nag-add up siya until 1. Pero yung additional, yung jump na yun, that's what you're counting as the probability at a specific point. Yeah. So, and then same thing here. So what this implies is na at points where it is whole numbers, where may value yung PMF, same lang siya sa CDF. So therefore, this is like the pedantic stuff sa mga true or false questions. This is technically false because it's supposed to be greater than I'll just write it down. Greater than or equal to. So, yeah. And just in general, that's how you read PMFs and CDFs. PMF 0 siya at any point that isn't whole numbers or is not included directly. So this is a more direct translation. Tapos yung CDF naman is more cumulative in the sense na yung jumps yung increase in probability when you're converting from PMF to CDF. I hope that made sense. So, yun. That's for number 7. For number 8, we've already established this, so we can just go back up here. A union B intersection is equal to A union B intersection A intersection B prime. Oh my god, that's my bad. Is equal to A prime union B prime. Yeah, this is just an intrinsic property, and therefore that is true. Last item naman is yung number 9. For discrete random variable, the variance represents the actual square of deviation of the random variable x from the mean. So as we've established kanina, yung variance is the average of the sum of squares from the mean. The average. And if you look at it, it sums up everything, diba? And then gets an estimate. Which means na it cannot be the actual. It is only the expected distance of square of the distance from the x from the mean. So because it is an average lang of the sum of squares or the sum of squares na distance from the mean, that means that it's not actual, it's just expected. So again, small like one word technicalities, this is false. So yun lang. That's for the entire conceptual part. Are there any questions? Was it masyado bang mabilis? I think on some items masyado. Wait, I will check chat again. Pero please do ask questions. And baka di ko siya ma-cover lahat then, in the most accurate way. Because I will also be taking the test this Tuesday, guys. So, ayan lang. It's not like I've already passed this course. So it's like halfway pa naman. I think, would you guys prefer diretso tayo and see if we can cover more problems? Or do we wanna rest for a bit and then continue na parang medyo slightly reset? This one, I will actually need you guys to talk kasi I need you guys' input. Okay, I saw the question. Sorry. Go, Miko.
Okay,
Continue?
okay.
Sige. Okay, I'll just answer the question first. Only geometric follows memoryless property. Wait. So I'm also referring to yung answer key na meron na. It does say. Oh, okay, wait. Let me just check this. Okay, that's my bad. Okay, so it's actually, tama na the first. So A1, sorry guys, all the way back to A1. This is actually false, and I think the reason for that is, actually don't know, pero let me think. Success on fourth trial, first two. I think you can't ignore it kasi there is a difference. You can't just discard, like let's say if it's something like this na, you can't just discard yung first four trials. If it says given na you already have like 3 previous successes. So maybe in this specific scenario it works, like coincidentally. Pero for multiple scenarios na, so when you're looking at fourth success at sixth trial na, so any case of the negative binomial na R is 1 or greater, in that case, hindi nagfo-follow yung memoryless property. Kasi the way you can think about it is, i-generalize mo siya. Ito yung scenarios where you already have 3 successes. Ito yung scenarios where you don't have 3 successes. If you start from here, you're breaking the total probability rule. Kasi this is just a subset of this. So, parang you can't technically you can't technically ignore na this already happened. Kasi this would mean na you're parang different yung denominator mo, which would completely break the equation. So yeah, thank you for pointing that out. I take full accountability for that. So false pala yung sagot dito. And I guess I can put out a more detailed solution pa when I, like, tomorrow or something, just to clarify it further. But yeah, especially to the people taking notes, my bad. Mali yung A1, it is false. Yeah. Okay, thank you for pointing that out, and sorry ulit. So, we can continue na to problem solving. Let's just do it one at a time, because I think the questions get harder as you go along. And I'm assuming some of these nga setup lang yung hinihingi, because like I tried solving them. They're like sometimes nagma-math error siya. So anyway, let's just go to problem solving. I'm assuming there are no further questions now. I'm just checking. Okay, so let's go to problem solving. An electronic fuse is produced by 5 production lines in a manufacturing operation. The fuses are costly and quite reliable, and are shipped to suppliers in 100 unit lots. Because testing is destructive, most buyers of the fuses test only a small number of fuses before deciding to accept or reject lots of incoming fuses. All 5 production lines usually produce only 2% defective fuses. Unfortunately, production line 1 suffered mechanical difficulty and produced 5% defectives during the previous month. This situation became known to the manufacturer after the fuses had been shipped. A customer received a lot produced last month and tested 3 fuses. One of the fuses failed. There are 2 questions. The first is, what is the probability that the lot was produced on line 1? And what is the probability that the lot came from one of the 4 other lines? So, this is like a pretty complex question already. I can't lie. But let's take it one by one. So let's just write down all our givens so we can like get an idea of what solution we're supposed to start with. So we know that the probability of failure, or in this case the desired outcome, kasi 'di ba, tinitest natin is the number of failures. So meaning yung desired outcome natin, like from a solving standpoint, is the failures. So the probability of line 2 to 5 is 0.02, and then the probability of failure on line 1 is 0.05. The other thing is yung sample size is 3. Yeah, yung sample size is 3, and then yung tinest na size is 1. K is equal to 1. And then, most importantly, and I think what is implied lang in the question, is the probability of a sample coming from line 1 to line 5 is equiprobable, right? It's equally likely na a sample came from line 1 up until line 5. So, it's important to note na the probability of something being produced from line 1, 2, 3, 4, and 5 is all 1/5. And what that means is na, to just get a grasp of our concept, we want to figure out the probability that the failure came from line 1, given that we have one failure. So, conditional probability to. The probability that it came from line 1, given that there was one failure. So, if we grasp the solution in like just word form, we have one failure in line 1. What is the probability of getting one failure in line 1? And then we weight that nga. We add a weight to that because it's 1/5 lang of all the lines. And then the total probability rule. So we also want to get the sum of the probabilities na there was one that failed in line 1 plus the probability that one failed in line 2. plus the probability that one failed in line 3, plus the probability, etc., etc. So, given na we already know this is a given in the problem, we want to get lang the sum of the scenarios where isa yung nag-fail, and kunyari, yung isa galing sa line 1, yung isa galing sa line 2. We want to get the probability of all those scenarios. So, in formal equation form, that means now we're getting the probability of the probability that it happened on line 1 given a 1 failed, and then the sum of all of that. So L1 considering 1 failed, L2 considering x equals 1, etc., etc. So now we have this as our working equation. Now we have this. So then, the next thing that we want to do is try to get something more productive out of it. Because it's hard to find pa rin, diba? Like the probability of L1 given the 1 failed, we don't have direct data on that. What we do have direct data on though is we can use a feature, like you can use something down the line to get the opposite of that. The probability na if we are taking line, given that the sample came from line 1 or line 2 or just any line, ano yung probability na one of those failed, right? Because we have a rate of failure for each individual line here. So what that means is, if we can parang swap the conditional probability, we can get a way to find kung ano yung probability of finding one failure given na the probability of getting one failure given that it came from a certain line. To swap those, we can use Bayes' theorem. So Bayes' theorem is basically when you kind of swap yung quote-unquote swap yung order niya, you have to multiply it by whatever's on the right and then divide it by whatever's on the left. I think yung 27 slides, if your mom, Sai or Sir Mark have the derivation for this, I'm not gonna explain it na. All you need to know is that when you swap, you have to multiply it and then divide it respectively. So what that leaves us is this. So we swapped it, diba? And then we multiplied. So we swapped it and then we multiplied obviously yung previous conditions. So I did this for line 1 and then I just repeated the same thing for line 1 ulit, line 2, line 3, line 4, line 5. No need to check those. Those are the exact same as this. Now, this is where like a bit of the, I guess, satisfying part, if you can call it that, happens. Remember from the given sa question, it is already known, it is certain na isa yung nag-fail, right? Yung hinahanap natin is ano yung likelihood na galing siya sa line 1, yung isa na pumalya. Like we know it already failed. And what that means is this is just basically 1. The probability na x equals 1 or one of the yung fuse, one of the fuses failed is 1 because we know that it happened. We know that that's what happened. So this is magka-cancel. This is just all 1. Okay. So now we basically have sa baba, we have now the probability of x equals 1 given line 1 times the probability of it coming from line 1 over the probability, I'm just gonna use summation para lang it stays on the same part of the screen. Summation from 1 to 5, the probability that x is equal to 1 given that it comes from line I equals 1 to 5, and then times the probability of Li. This is nothing fancy, guys. Like this is just like tinatamad lang magsulat in full, and it's not visible on the screen. So the next thing that we want to do, just to simplify this further, is, remember, now this is all just 1/5. So this is kind of like, you can treat it like a constant. This will not change regardless of whatever L sub I is. What regardless of whatever L sub I is, it'll always be 1/5. So this is 1/5. We know this to be one over, no, not cancel. We know this to be 1/5, and this will always be 1/5, diba? And then you can remember, you can like bring out constants kapag nagsa-summation ka, diba? So we can bring this out. And this becomes 1/5. And then you can just cancel the 1/5. Technically. You might be thinking, so ba't pa tayo nag 1/5 dito if we're just gonna cancel it out? The answer is like, they're probably gonna like deduct solution points from that if we don't acknowledge na yung probability na it came from any of the lines is 1/5, even though the solution technically works without it. So anyway, now we're left with the probability na isa yung nasira given na it's line 1 versus over the probability na isa yung nasira, it came from all 5 of the lines. So summation 1 to 5, I equals 1. So then we can bring out some values already. This is relatively simpler to solve because we have the data for it. What we are going to use is I brought it out here. What we are going to use is the binomial distribution. Diba? Kasi the reason for that is 1, so yung conditions nga for binomial distribution, if it's 1, parang if it's in sequence. 2 is if it's without replacement. But 3, if the probability is if wala siyang certain rate of failure, if all you know is na you have one, if all you know is na there's a likelihood na it like happened and wala kang clear na rate, even though we have the explicit scenario na 1 failed, we don't have the specific volume of failure for each of the individual lines, if that makes sense. So what that means is na we have to use the probabilities given here, which are 0.02 and 0.05 respectively. What that means is this effectively just becomes 3 choose 1. Nang 3 choose 1 came from the fact na 3 yung trinay as per the question. So tested 3 fuses, 1 failed. So tested 3 fuses, 1 failed. So that's why it's 3 choose 1. And then the probability of failure for line 1, diba, it is 5% because of the manufacturing problem. That is 0.05 times 1. I raised to the 1, which is just basically nothing. And then the probability of the invert, like the complement, the other part. So that's just 1 minus 0.05, or diretso ko na as 0.95. Because we tried 3 things and 1 failed, that means na we had 1 that failed or 1 that got the desired outcome, and then 2 that didn't get the desired outcomes. So 2. So basically, this is it for the top part. For the bottom part naman, we'll have to do this 5 times. So 3 choose 1, 0. So let's just copy first things. 0.05, 0.95 times 2 plus let's start with line 2. So for line 2 naman, we still get the scenario na nag-3 choose 1 ka. Diba? So it's still the probability na, ay, sa line 2 pala siya. 0.02, right? Makes sense kasi this is what was given. Yun yung failure rate niya, 0.02. So this is 0.02 raised to 1 naman. And then this is 0.98 because it's just 1 minus p, right? So 0.98 to the 2 kasi 3 choose 1. Okay. Technically, uulitin mo lang yan for line 3, line 4, and line 5. Which is kind of hassle to write down in full. So in this scenario, we can get away with just writing 4 here because it will just happen 4 times. But technically, if iba-iba yung probabilities per production line, you would have to add every single one individually. But in this case, it's the same. So I guess if you guys weren't following, now would be a good time. Siguro para just to practice inputting numbers din. Is practically the near final answer already, and it should give you a value of 0.37. Can somebody confirm this? I'm assuming some people are doing it, right? Tao. Okay, thank you. Sige. I'm just also gonna check if I messed up ulit somewhere. Okay, so this is... Okay, mo tama naman. Okay. Sige, let me know if this is the one you got then. Ayun. Okay, so somebody got it. Sige, thank you. So, that's basically the final answer for this. That means that if one of them failed, there's a 37% chance na the failure was produced specifically by line 1. And then the follow-up question here is now, what is the probability that the lot came from one of the 4 other lines? That just means na you have to minus it by 1, diba? Kasi the probability of it coming from line 1, the failure coming from line 1, probability it came from line 2, plus the probability it came from line 3, etc., is just equal to 1. So that means na it's just a matter of rearranging it, moving it here. Therefore, the probability na it came from the other 4 lines is just 1 minus, not L5, L1 pala yung nakuha natin. Sorry. Yan. The probability na it came from all the other 4 lines is just 1 minus the probability na it came from line, which is just 1 minus 0.37, which is 0.63. So that's for the second part of the first problem. So that's basically problem 1. Okay. So let's move. I'm assuming there are no questions na. Any clarifications? Any part that doesn't make sense fully? Please do say them now. Para naman we can. Okay. I'm assuming there are no questions now. I think this will probably be the last item because this is also such a tough one to solve. So my bad, guys. I don't think we'll be able to cover problem 3 and 4. Luckily though, my detailed naman yung solution doc for this. And if I'm being completely honest, I don't think I can explain it well then. It's a very tough question. These are very tough questions, yung 3 and 4. So I'll do my best na lang sa 2 to make up for it. So number 2 naman, the number of text messages that are received by Jack's phone can be modeled as a Poisson random variable with a mean of 1 for every 16 hours. Similarly, the number of text messages that are received by Jill's cell phone can be modeled as a Poisson random variable with a mean of 1 every 12 hours. Jack is happy whenever he receives at least one text message per day, while Jill is happy whenever she receives more than one text message per day. What is the probability that none of them is happy in at least 5 days of a week? So, the first thing here is na it's a bit confusing kasi the last part of the problem, diba? Parang it makes sense to use binomial kasi it's sampling out of a week how many times are they unhappy for at least 5 days. But at the same time, sa start ng question, they said it would be Poisson. The answer is for this question. For this question, you will have to do both. And specifically, what you will have to do to get both is parang hahanapin mo yung probability that they are both unhappy, and you will use that using you will do 2 steps to get that. Una is hahanapin mo yung probability that Jack is unhappy, and then kukunin mo through Poisson yung probability na Jill is unhappy, and then you get the intersection of that, which will give you the probability that they are both unhappy, which is what we're looking for. And then when you get that probability, you will plug that into the binomial. So yun yung P na gagamitin mo in binomial RV to give you the final answer of when they're unhappy at least 5 days of the week. Okay. Before I proceed, para naman I think better masabayan yung pag-solve natin. Is that clear muna yung approach na we're gonna do? And does it make sense why?
Well, yes. Okay.
Okay. I'm gonna assume that's like actually a yes. So, okay, I think I underestimated the space na kailangan. So, I'll just move to a new page. Okay. So let's first find the probability na Jack is unhappy. So we can model this using Poisson. So note again na yung condition for happiness ni Jack is na he gets one message a day, at least one. So his happy condition is unhappy condition, is basically this. X is greater than or equal to 1. So given that this is discrete and not continuous, we can just assume that this is also equal. Now this is basically like 1 minus P. X is equal to 0. So what that means is, so just 1 minus 1 plus P x equals 0, we're just looking for, so therefore what this means is na yung unhappiness scenario ni Jack is at px equals 0. So let's do that. But first, let's find lambda. Lambda is 1 every 16 hours. 1 per 16 hours. But if you guys can see, you guys recall sa dulo ng question, it asks for at least 5 days 5 days in a week. So what this signals to us is we have to convert it into days na in advance, so that when you get to the end of the question, it'll all like the data we get will be applicable to the yung sa dulo ng question. So this means also that we have 1.5 per 24 hours or 1 day. Wait, before that makes sense naman, I'm assuming. So, okay. So our lambda therefore is 1.5 per 24 hours. So, going further, f of 0 is equal to e to the negative 1.5 1.5 times x or times 0 over 0 factorial, which is somebody pull out their calc. Wait, I will na rin. E to the negative 1.5 times 1.5 raised to 0 factorial. That got me 0.2231. Sige, please message ASAP if it is wrong pala, as you guys are rechecking, kasi it will affect the whole problem, and then I will be very frustrated kasi I will have to redo everything if mali pala siya. Okay, so next naman, what we're gonna look for is yung unhappiness probability naman ni Jill. So si Jill naman, they need from the question here, p greater than 1 to be happy. That implies na for them to be unhappy, 1 minus p, x is greater than 1. Which also implies na it's either 1 or 0. So this means that it's 1 minus 1 minus and then 1 minus p 1 plus p 0. Okay, so then same procedure as dati. This will cancel, double negative yan, and then applies to both. So basically, hinahanap lang natin yung case she's unhappy when you get the sum of P1 and P0, or yeah. So we simply plug it into the Poisson equation again. So F1 is equal to, I forgot. The next thing we have to find is their lambda naman. So they get, on average, yung rate niya is 1 every 12 hours. Which means na 1 per 12 hours. Again, converting it to days is 2 per 24 hours. So, this means na yung lambda natin is quite simply 2. So then we can plug it in for real this time. F0 is just equal to E times e to the negative 2 times 2, first case, times 0 to the 0 factorial. F1 on the other hand is just the same thing, but syempre yung iniba is yung exponent. So 1 factorial. You guys can do the summation thing. I'm assuming tinuro na yan in your guys' classes, like how to use. So then that'll give you 0 factorial. So the first one gives me 0.13533, etc. Just kindly verify if that's the case. And then next up is yung case naman where f is 1, where x is 1, and you plug it into f. This one gave me 0.2706, etc. 671, etc., etc. So then, we add those together, which should give us roughly 0.406006. I'm assuming people are still counter checking my arithmetic at this point. I hope, but at least sure tayo. So this is it. These two are the probabilities of them being unhappy. Now, the next thing to note is na obviously, wala ring sinabi sa question na like Jack's happiness is dependent on Jill and vice versa. So we are going to assume na these are independent events. And because they are independent events, that means na the likelihood that they are both unhappy is just the direct multiplication rule lang. So if you multiply those together, P Jack unhappy times P Jill unhappy, you'll just end up, if you multiply them together, you will end up with 0.090, sorry, 0.090592. Okay. So then, this will be our probability na gagamitin natin sa next part of the solution, which is the part where we do binomial. Before we move on to the next part, I just want to make sure wala na talagang tanong. Sige, I'm gonna assume this is all good. But yeah, so now, what we are going to do is just use yung traditional na binomial. So again, this is not, I guess it should be less intimidating na kasi we're not really we have one step left to go. So I hope na it's like somewhat familiar na ulit, as opposed to nung intimidating pa siya kasi 2 parts. So now, we look for the number of days in which none of them is happy. So this is the probability na none of them is happy. So now, we look for P X is greater than or equal to 5. So, the sample again is 1 week. So, it's 5 to 7, diba? Ibig sabihin yan, we can use summation. X is equal to 5 up until 7. And then just use yung traditional binomial. Wait, I will pull it up for your reference now. Wait, did I write it down? I did not write it down nga pala. Sige. So binomial distribution is just sample size, sample size, and then success cases, and then you multiply that with the probability of success times the amount of successes needed. So same sila dapat lagi. Tapos 1 minus P, which is the probability of failure technically. And then that is multiplied by the this is wait yeah this wait lang, sorry, this is minus x and minus x. Yan. Okay, there we go. So plugging that all in, we have 7 obviously kasi that's the amount of days we're measuring. This one is just x because we are using summation. Pero technically this is 5 sa first case, 6 sa second case, 7 sa third case. And then p, we can just plug in 0.090592 to the x times 1 minus p. That is approximately 0.909408 7 minus x. This is a format you can plug into your calc na, which you guys should practice doing also kasi it actually makes a big difference in time whether or not you know how to run your calculator properly. So then, adding up that all together. So again, this is just, you add it. So you plug in x equals 5, and then you add it with a case where you plug in x is equal to 6, and then x is equal to 7. So, from your calc, you should be able to get na the answer to this is 0.0003010,954. So there is like a 1 in 10,000 chance na they are both unhappy for at least 5 of the 7 days. So yeah, that is the second question and the last for tonight. Alright, we have like 10 minutes pa, pero you know, I don't think anyone wants to use it. So that's okay. We're good with that. Are there any questions? Okay, I'm assuming none. So thank you ulit, guys. Admittedly, this is like not the most comprehensive, but I still hope na I was like able to add value. Na worth yung 2 hours nyo. Again, since this is like the first time Acadcom is live streaming these na, so that we can just use it in the long term. You guys can always just come back to this review session. Technically, so for now on Adam's YouTube channel, pero we will migrate it to the official IE Club account very soon. So ayun lang. Can we like take a pic for documentation lang ng Acadcom? I will stop sharing my screen. Jerome, can you screenshot ba or Mina? Okay, thank you. But yeah, while we're waiting for Jerome, questions. Assuming wala na. Okay, game. Everybody who can, please turn on your cams. Yay. Okay lang yan. Lahat tayo. Brain fried. Right. I'll start na nga para people will do it. Yan. I'll put my glasses on. Okay, thank you. Let's go. 9:53 final. We will take the pick so we can all have our EP time. Oh, dude. That's crazy. Tinatry ko yung number 4 kanina. And I was just like, so, oh my god. If that comes up sa LE, I'm like, I don't think it will. Because legit nagma-math error siya when you try it on. So I'm hoping. Anyway, K953 game pick tayo. Jerome, on your account na lang. If you can.
Okay, I will, but my brother's a bit loud. Wag niyo na lang pansinin.
That makes him disappear.
Three.
Yes, there's like a loop.
Oh, hi, Miko.
Or like
3, 2,
Master Bay goes on the
1.
adventure to save himself.
Three,
Going on the
two,
adventure
one.
like is what causes him to disappear.
Thank you
So-
for coming, guys.
Thank you guys. Sobrang last minute niya ulit because we just came from 40. But thank you for coming pa rin. Hope you guys learned something or something like added value to your review. I guess just stay tuned because obviously ACAD engagements will do the rest of the exams, ideally for 27 and 40. For transparency, we are in the process of getting a semi-permanent tutor for 27 who actually took the course na. So I don't have to wing it like paminsan-minsan. Yeah, so if you know anyone pala from upper years who was very good at 27, please let us know para we can tap them. But yeah, expect to see more from us na lang. Ideally, more systemized na siya. So it doesn't have to be like at 10 p.m. on a Saturday night. But regardless, thank you pa rin guys. And good luck in the exam this Tuesday. Ayun lang. Rest well guys. Good night.
But yeah, I mean, like, it's
Thank you.